This is the second video where we're going to look at some examples in both mesh current and node voltage equations for different problems. So we'll start this one out with node voltage. First, identifying my nodes. So this one, notice, is a common node because the only thing through there is a short. So that would be my V1. This would be my V2, and we'll select this bottom, which is also common, as our reference. So in the node voltage method, we're only going to have two unknowns. So at least initially, it looks like node voltage might be easier. Also, the question is, we were asked to find, these voltages and this current. So if we set this up with node voltage, we'll solve for these voltages directly. So it could be that in this problem, node voltage is the easier choice. So first, let's write the node equations, which in this case will be very simple because we have no voltage sources, no dependent sources, nothing like that. So we'll have minus 15 amps plus V1 over 60 plus V1 over 15 plus V1 minus V2 over 5 is equal to 0. And then let's look at node 2. We have V2 minus V1 over 5. We have V2 over 2. And we have plus 5 is equal to 0. So those are our node voltage equations. I think people don't like node voltage because it involves the 1 over R term. So you've got V over R, so you generate some fractions, which makes the equations look more difficult to solve. But in this particular case, I think node voltage is pretty easy. I'm not going to solve these because that just takes up so much video time, and these videos take up a lot of storage space and time. So rather than solve, I'll just present these two equations, and then what I want to do is I want to look at the same problem done with mesh current, because everybody tends to love mesh currents. We'll paste the same circuit, and let's look at what happens if we use mesh current. Now, upon initial inspection, it looks like this would be a difficult problem for mesh current because we have 4 meshes. And what I want to do is, because they have a lot of blue on this circuit, I want to use red for mesh currents. So if we look here, and let me just set it up, pretending that, I don't really know what I'm doing here. And so we'll do I1. Oh, you know what? Let me go back, because I do want to point out one thing, because one of the things that we wanted to solve for in this circuit was I1. So the way to get that is to look at what is I1 in terms of the node voltage. Well, it's this current through this 5 ohm resistor. So it's basically V1 minus V2, which is the voltage across the 5 ohm resistor, divided by 5 ohms. So to fully solve the circuit, you would need to have this equation as well, which is not a node voltage equation. It's not a source equation. It's not any kind of equation that's necessary to solve for the node voltages. But what it is it's a variable in the circuit that the question was asking for you to solve for. So after you solve for the node voltages, you plug those in so that you can get that current. Okay, sorry, that was an important point I wanted to make. Now back to mesh current. So we have I1, I2, I3, and I4. So I1 is actually equal to 15 amps because there is a current source here on an outside branch. I4 is equal to 5 amps because it is defined in the same direction as this 5 amp current source on an outside branch. So two of those mesh currents are already solved for. Let's look at mesh 2. I'll have 60 times I2 minus I1, which is 15. And then I'll have 15 times I2 minus I3, and that's equal to 0. And now looking at mesh 3, I have 15 I3 minus I2, and then I have 5 I3 and 2 I3 minus I4, which in this case is 5 amps, and that's equal to 0. Okay, so what the problem is actually asking for is I1, their little I1. That's equal to my big I3. So you notice that I came in independent of what the problem was asking for. I defined my own mesh currents with my own variables that made sense to me. I set it up, I wrote all the equations. I would have solved for I2 and I3. Once I do that, then I go back and I look at what the